Hey everybody, welcome to the Sediment Settlement Lab. This lab is really designed to get you a little bit more intimately connected with how sediments work in the natural environment. We're actually going to be creating sediment tubes, and these are these clear tubes. We're going to put a stopper in them, and we're going to fill them up with water and different sediment samples, and we're going to time how long it takes those sediments to settle down to the bottom, kind of mimicking what would happen in the natural environment, trying to see what these different types of habitats look like, such as on the beach versus the estuary like the lake or lagoon, or even a lake. Those are going to be our three spots. So the first thing we need to do is go out into the field and collect these sediment samples. So let's go. Hey guys, so we're here at the beach and we're going to collect our first sample of sediments, and that is right here at the coast. And of course, we want to make sure that we label everything, right? Alright, let's go to the next spot. Alright guys, we're here at the shores of the Lake Worth Lagoon right in front of Snook Islands, and we're going to collect our second sand sample right here. Alright. Got it in there, got it labeled. Good to go. So I'm here at the third site, which is at Lake Osborne. So it's one of our inland lakes, and so we're going to take some samples here from this mucky zone, which has a lot of organics in it, for sure. I could cut some good perches here. There we go. Alright, we're going to label this up. Of course. Here we go. All right, now that we're back in the lab, let's go ahead and take a little look under the hood first. Essentially, I've got some Petri dishes set up here as a base, and we're going to put just a little bit of each type of sediment. There's the beach sand. And here is the sand from the a little bit more grainy from the lagoon. There we go. And now we're going to have a little bit of sediment from the mucky lake bottom. There we go. So now we're going to set these up in the dissecting scope or the stereoscope. Essentially, it allows us to see things a little bit closer than we would normally see them, and try and kind of get a better grip on what we're going to be seeing in the settlement tubes. So let's take a look. The beach sediment, you can actually see fragments of shells, which is all the kind of red and brown and kind of beige colors. The crystal clear components are the quartzite sand. In the lagoon sediments, you can see it's almost all quartzite sand, although there are a few little pieces of shell, that really white piece up the top, for example, and a couple other detrital matter pieces. The lake sediment is completely gucked up with brown detritus, but there is some quartzite sand mixed in as well. All right, now that we know what these sediments look like up close, let's go ahead and get started with the lab itself. First thing we're going to do is take the sediments from the sample containers and actually try and get a uniform volume for our settlement tubes. Now I'm going to use these beakers. I'm filling them up to about 200 milliliters for each of the different sediment samples. So you can see as I'm scooping it and leveling it all off. And of course, there they are, all ready to go. Now I'm going to transfer those sediment samples from the beakers into each of the different settlement tubes. Now we're going to add water. We're going to fill each of the settlement tubes up to about the same level of water, about 35 centimeters, I believe. Now it's time for the fun part. I'm going to do a big shake, shake, shake for each tube to get them all started. And of course, as soon as I set it down, the clock is ticking. And you can see just with the beach sample how fast the beach sand settles to the bottom. I barely can get to the other end of the two tubes without there being relatively settled out in that sample. So about a minute in, and you can already tell that the beach sample has completely settled out. There's really no particulates in the water column. It's all good to go. The lagoon sediment, however, is still suspended. A lot of larger sand grains are already down, but it's still pretty murky. However, if you look at the lake muck sediment, it is nowhere near clear. It is totally opaque, totally suspended. After about 4 minutes, the lagoon sample has mostly settled out except for just a haziness, which I'm still waiting to go away. However, the lake sample is completely still suspended. At about 20 minutes now, you can actually see in the lake tube a kind of a surface for the sediments to be setting down upon, but there's still plenty of suspended particulates. Now we're an hour in, the lagoon sample still has some clarity issues, and of course the muck lake sample still has suspended particulates. Now we're at 4 hours and 30 minutes, roughly 270 minutes in, and I can finally call that the particulates are settled out in the lake muck tube. And we are back. It is 24 hours later. It really actually took that long for the water to get completely clear over here in the lake muck sediment tube, which is kind of interesting. And of course, we can sort of look at this in terms of large scale here, right? When we look at the beach sand, it actually settled relatively quickly in terms of all the sediments. In fact, just about 30 seconds in this first trial. Now the clarity came just a little bit after, a couple minutes after, but still it settled out pretty quickly. The lagoon sample didn't take too long either, about 4 minutes or so, and most of the sediments had settled to the bottom. The clarity again took a little bit longer. It took a few more hours, around 390 minutes, before it got really clear. But the lake muck sample really took a while. It took about 270 minutes for it to really fully kind of settle, but for full clarity, it took the whole 24 hours just to get that. Now we're gonna focus on graphing just the first column, the particulate, but I wanted to show the clarity ratio too, just because it's kind of interesting. And of course, this all ties into what's going on in the environment, right? With the beach, you have a much more dynamic environment, lots of waves, currents, tides, things like that going on. And so a lot of the smaller suspended sediments are just going to go farther downstream somewhere. They're going to go with the current. And so the stuff that's settling out is the larger grains of sand and shell fragments, things like that. Whereas in the lagoon sample, yes, there are some currents and some waves and stuff, but it's not nearly as much. And so you have a much finer grain of sediment that actually settles out in this area. But still, again, it is somewhat dynamic. But when you go over to the lake in this muddy shore, you really don't have a lot of currents going on at all. And so all of the detrital material just sort of builds up and creates this kind of mucky area. And that could not exist in the other two locations. Now, in the Lake Worth Lagoon in general, and the estuaries in general, and some of the back channels and stuff like Munyon Island and whatnot, you can get that same sort of muck, even if it's not a lake. You can get it in the estuary too. So it really has a propensity to what kind of current, level of current and water movement you have in the area as to when the particles settle out. The larger grains of sand and pebbles are going to settle out first in high movement water. The smaller particulates, the silts and such, they have to have a much more calmer environment to be able to actually settle to the bottom. And so that actually also talks about transport, what kind of particulates get transported farther, and so on and so forth. Now, if you actually look a little bit closer at the different columns, the different profiles within the tubes, you'll notice that the sand in the ocean, the beach tube, is relatively uniform across the entire profile. Whereas in the lagoon, you'll notice that there's some larger pebbles and grain sizes towards the bottom of the profile compared to the top, where it's more smaller, finer grains of sand and sediment. And then of course over in the lake, you'll also see the same thing, where the sand, the particulate sand, probably like the quartzite sand, stuff like that, is all at the bottom, and then the detrital material is sifted and sorted from larger to much more fine sediments towards the top of the column. So these are also just observations that you can make based on what's going on. Now, we're going to go ahead and show you the next two trials and the first trial, so you can write all your data down, and let's check it out. Now that you have all your data, let's just kind of think about this in terms of larger scale. So the whole reason why we do these types of experiments is to sort of model what would happen, so that when we're looking into the actual environment, which has a bunch of other factors going on, right, we can have some idea of what the outcome of a particular situation would be. And in this particular instance, we're looking at that particulate size. So you're out in an estuary and you're looking and you see a very mucky area, your feet are sinking in there, it's really hard to walk around. The very, very soft sediments, that there's probably not a lot of water current in the area throughout the day and night cycles, specifically the tidal cycle. Areas that you have much more sand and kind of more solid environment, that there's probably a lot more water current moving that fine particulate somewhere else. So it gives you that idea between the different shores. And of course, you could be asked about that on a test in terms of the different characteristics of the various different shorelines as well. And so this is just an insight in there to get some ideas about what it would actually be like out there in the field, what these different situations are like in the different habitats. And of course, understanding that helps us better manage the environment as well. And so I'm going to leave it at that. And of course, until next time, keep learning.